So you got division of polynomials. Number 1, put the polynomials into standard form. It's important. What is standard form? It's a polynomial from highest to lowest powers. And if we're missing something, we need to have a placeholder. So if the highest exponent is the 5th power, and then it goes on to put something like 3x squared, you're missing 2 terms. You're missing an x to the 4th and missing x to the 3rd. So you need to put 0x to the 4th and 0x cubed on there to make it work. So make sure we have our zeros. The reason why we have these placeholders is that everything needs to have its own column. You need to set up that division bar. The division bar with the divisor on the outside, your dividend on the inside. And the question that you need to be answering all the time is, what is going to make the leading term of the divisor, the outside one, the same as the leading term of the dividend, the inside one, and then you can place that on top of the appropriate column of what it is. Once you find what you have to multiply to make them the same, you will multiply that to all the parts in the divisor and then subtract them. Watch negatives, because when you subtract a negative, you are actually adding. So be very careful on that. And just like when you're washing your hair in the morning, rinse and repeat. So, you have, repeat this, guys, with the new polynomial after you've done your subtraction until you get to the constant column and you run out of ways to make the leading terms the same. Anything that's a leftover, we call a remainder, and is added at the end over what you're dividing by. So again, until we start working on the problems, it doesn't make perfect sense yet. Again, I wanted this to be workable for any problems that you're about dividing polynomials. So, let's start off real easy. Let's do numbers. Let's do long division with numbers. Now, the question, if you guys remember, doing long division was, I want to divide 25 into 4,025. Can 25 be divisible into 4? No. No. So I usually then look at the second number along with it. Can 25 go into 40? How many times? Once. So what do I do? I put a 1 above the 0 because I'm starting at the second number.
Wait, this is it? This is just how you divide?
Yes. This is long division. This is not with polynomials yet. What do I do with that 1? I multiply it. I'm going to take the 1 and distribute or multiply it to 25 to get 25, and I put it underneath the 40. At this point, I will subtract. And what's 40 minus 25? 15. And then you kind of ask yourself, does 25 go into 15? No. So therefore, I'm going to bring what into this whole thing? I'm going to bring a 2 down. And now, does 25 go into 152? 6 times. So therefore, I put a 6 above the, and I use the 6 and multiply it to the 25 to get 150. And when I subtract, I'm left with the 2. Not enough, so I bring down the 5, and we find out it's 1 time which will give me 25, which will give me a remainder of 0. So you end up with a 0 remainder. That's long division using numbers. Hopefully that's a good review of what you need to do. Unfortunately, it's not going to stay that way. We're going to use polynomials. Here we go. So if I look at these polynomials, we have to follow our steps. The first step said they have to be in standard form. They're not in standard form. So let's just put them in standard form. I want to divide the first one by negative 3 minus x. So to put them in standard form, what would it look like? 4x cubed minus 2x squared plus 4x plus 2 by x minus 3. Now that looks a little bit nicer from what we've seen in the past. Uniforms a few things for us. Now we have to set it up. What goes inside? What goes outside? X minus 3 goes on the outside. Now, there are some things, the outside, your divisor, you don't need placeholders. But inside, you would need placeholders if we need them. Looking at our problem, what's the highest exponent? The lowest one is a constant. Is there anything missing in between? No. So we don't need any placeholders. That's the thought process. So 4x cubed minus 2x squared plus 4x plus 2. And all of that should fit underneath your divisor or your fraction bar. Yes? So, using our process, the question that needs to be answered, you need to ask yourself is, what times x will give me a 4x cubed? 4x squared. And so I'm going to take that, it's an x squared. I'm going to place it over the x squareds. So it becomes a 4x squared above there. I'm going to keep all my x squareds, all my x cubes, all my x's and constants all in a nice neat rows and columns, or columns in this case. Then, the next step says I take that 4x squared and multiply to the x and the negative 3. What's 4x squared times x? 4x cubed. We engineered it that way because the step after this is to subtract. And when you subtract the same thing, they disappear. And you also need to multiply the 4x squared to the negative 3 to get a negative 12x squared. Is everyone okay with that? Yes. I distributed the 4x squared to the dividend, or to the divisor, sorry. The thing on the outside. Next step says subtract. So what I like to do is I like to write subtract next to that. So I know I'm subtracting because it does get a little bit confusing when all of a sudden we're like, oh yeah, 4x cubed minus 4x cubed, that's gone. We engineered that to happen. We want that to happen. But here's the issue. It's negative 2x squared minus a negative 12x squared. You are taking a negative 2 and subtracting negative 12. When you subtract a negative, you are adding, which ends up being 10. 10x squared. Now, at this point, I'm going to start over again. So what I'm going to do is I'm just going to bring everything else along for the ride. So it's like I got a whole new polynomial, and I'm going to do it again. So if you can get through one of these steps, the rest of them, it's just the same thing over and over and over again until you can't do it anymore. So the question now is, you ask yourself, how do I make an x a 10x squared? Get it to be a 10x squared. It is times positive 10x. And since it's an x, I'm going to put it over the x column. 10x times, ran out of room there, okay. X is 10x squared. 10x times a negative 3, there you go, 30x. And I'm going to subtract. 10x squared minus 10x squared. There's 0. It's awesome. 4x minus a negative 30x. No, it's not negative 26. It's 34. 34x, bring the 2 along for the ride, and do it again. How do I make an x a 34x? Times it by 34. 34 times x, 34x. 34 times negative 3 is a negative 102. 102. 30 plus 30 plus 30 is 90. 4 plus 4 plus 4 is 12. And so 90 plus 12 is, or 90 plus 12 is 102. Subtract. The 34x's will. And when you subtract a negative 102, you're adding to get 104. Hopefully you guys are starting to catch that subtract a negative, you add thing. And you do it all over again, but here's the thing. You ask yourself, how can I make x become a 104? Well, you could multiply by 1 over x or something to get rid of the x, but I don't want to do that. I'm trying to multiply by some nice whole number stuff here, right? Is my objective. It doesn't always turn out to be nice whole numbers. So that right there tells you that you can't. Second thing, is there any more room above? No, there's no more room here. So I ran out of room, I ran out of space, so that anything left over is be a decimal, would normally be our remainder, right? So I'm not going to put R, remainder R 104, because that's what sometimes we do with our number ones. This one, I'm going to add it. I'm going to add 104. It's 104 out of x minus 3. And so your answer is all of the stuff that you just created. And the cool thing is, guys, we found that by dividing by x minus 3. If I took x minus 3 and multiplied it to the big purple circle, I would get the original number of 4x cubed minus 2x squared plus 4x plus 2 back. So on this particular problem, we're going from a degree of 3 all the way to the constant. That means there's stuff missing. We need to put our placeholders in. And so when I go to set this up, x minus 1 is definitely on the outside. Inside, though, starts off with x cubed plus 0x squared plus 0x minus 2. You need every placeholder between or not included. Number 1, it helps us identify our columns. Okay, that's pretty much the important thing there, because as we are doing this problem, we will come up with x squareds and x's, and we'll need to have a place for them as part of your answer. Think of it. You're dividing a cubic by a linear problem, or x cubed divided by x, which would lead us with an x squared, right? By definition. That's how you add powers or subtract powers when you're working with exponents, by multiplying and dividing. So, question that comes up, how do I make x and x cubed? x squared. And I'm going to distribute through now. X squared times x is x cubed. We engineer that to happen. It should always happen. And x squared times negative 1 is a negative x squared. Now I'm hoping we're pretty proficient. The fact that we know we're going to subtract, the x cubes will cancel away. That's awesome. But what's it going to leave us with?
Negative.
A positive x squared. You're subtracting a negative x squared from nothing, leads us to a positive x squared. And I'm going to start over again, so I'm just going to restart everything, or drop everything here. Notice that I brought the 0x with me. I don't want to lose that. And how do you make an x? An x squared. X to get x squared. Multiply it by a positive x. And an x times x is x squared. And x times negative 1. Negative x. Again, you are going to subtract. And therefore x squared minus x squared. And so when you subtract a negative x from 0 is positive x. Bring the negative 2 down. And ask yourself, how do I make an x look like an x? Multiply it by 1. So 1 times x is x. 1 times negative 1 is negative 1. Writing subtract. Is everybody okay so far? And x minus x gone. Negative 2 minus a negative 1. Negative 1. It's negative 1. It is negative 1. Negative 2 minus a negative 1. That means you are adding what's negative 2 plus 1? Negative 1. So, here we go. Is there any room left at the end? No. And can I make an x become a constant? No. So therefore, it's not plus this time. You can do plus. But why don't I just say minus 1 over x minus 1. You could do plus a negative 1 over x minus 1. That's okay. Or you could subtract the positive. That right there is the answer. Lesson 16, day 2. Your homework is page 125, 10, which is the only one that deals with long division, and then 12 and 20. Have a great day.